Welcome back, everyone, and Happy New Year to everyone watching this. I'm back with a new video on continuing with my research methods videos that I promised you guys. Um, I just have a few more after this, then I'll get into the P1 content, and I'll still have a few more studies to upload, including two of the newer studies, Hassett and Holzel. A lot of you have been asking for those. So a lot of that will be coming. We are getting closer to the exam date, so I'll be uploading a lot more content a lot more frequently. So stay tuned to the channel and join the WhatsApp group as well for regular updates. Today we're doing a short topic. I wanted to do this separately from the research methods video, even though it is a part of research methods, but this is purely on statistics. It's called data analysis. And now I know some of you may not be too excited about this particular topic because not everyone is great at math and stats. But the good news for you guys is that for those of you who don't really have a strong grip over numbers and numericals and statistics, you don't really have to calculate anything. So this is not a math exam, it's a psychology exam. So it's not like you'll ever be given an equation and you'll be asked to calculate something. What is important is the content, the explanations, the definitions of different data analysis terms. So that's basically what we're going to be covering over here. So we have three main topics under data analysis. These are measures of central tendencies, which is also referred to as measures of averages. Then we have measures of spread, which we also call measures of deviation or measures of dispersion, sorry. And it can also at times be called descriptive statistics. And then the third topic will be some of the graphs and the charts that we have. So we'll start off with the first topic, measures of central tendency. Now, I've written averages in bracket because in your exam, if they ask you what are some of the measures of averages, then students shouldn't get confused because measures of central tendency and averages are essentially the same thing. There are three average scores, and I'm sure all of you are familiar with these. They are your mean, median, and mode. Now, what are we required to know about these three things? We should know their definitions, we should know how each of these are calculated, and we should know when it is most appropriate to use each of these three. So the different type of questions that can come in paper 2 could be a question where they've given you some content, they've given you some data, and they say that the researchers calculate the mean, let's say age or the mean scores or whatever it is that we're looking at in that study. And then they could ask you, how was this mean calculated? So you would need to write down the formula for that particular measure of central tendency that they're asking you. Um, Apart from that, they can even ask you why it is more appropriate to calculate the mean for the data that has been provided as opposed to any other measure of central tendency, or why maybe another measure of central tendency would be more appropriate than the mean. So just questions like that, about the formula, about the definition, and about when and why it is appropriate to use each of these. So let's look at them. Mean, also referred to as the arithmetic mean. How do we calculate this? I'm sure all of you know this. But if a question comes and you're required to write down the definition about how it's calculated, you can simply say that it is calculated by adding all the values of a data set and dividing it by the total number of values. So just to give you a very simple example to understand this, let's say we have a class of students and I want to take the average score of 5 students. So let me check if my pen is working. Yes, it is. Okay, so there's a test out of 10 marks, and I have 5 students. One student gets a score of 3 on 10. The other student gets a score of 7 on 10. third one gets a score of 5, fourth one gets a score of 5 as well, and the last one gets a score, let's say, of 10 on 10. So these are the 5 scores out of 10 that 5 students in my classroom have attained. Now I want to get the mean or the average score of these 5 students in this test out of 10. So mean is simply calculated by the sum of all the values in the data set, which means 3 plus 7 plus 5 plus 5 plus 10 divided by the total number of values. How many values do we have? We have 1, 2, 3, 4, 5. So the denominator would be 5, which basically is 7 plus 3, 10, 20, 30 divided by 5, which equals 6. So the mean score of these 5 students in this test is 6 out of 10. Okay, so I'm pretty sure I don't have to go into too much detail in explaining this, but just to give you guys an example of how it's calculated, this is basically the way that you can calculate the mean. Now, I've added another point over here, when it is most suitable or appropriate to use. So if a question ever comes saying why is the mean used or why would it be better to use the mean, you would just simply say because the data is on a numerical scale or the data is numerical and on a universal scale and it takes into account all the values of a data set. So what does that mean? So firstly, data that is numerical obviously means that it's data that is in the form of numbers, as you can see over here, and on a universal scale. Universal scale basically means this is a scale or a unit that is accepted universally. For example, in this particular question, I am assessing students' marks, right? If I were to take another example, let's say the average age of these um, 5 students, let's say it comes to 17. Now, age is often measured in the unit of years or even months if they're children, young children, but commonly the preferred unit that we use that is associated with age is that of years. Similarly, for height, it is feet or meters. For weight, it could be pounds or kg. So these are all units that are in a way accepted by everyone all over the world. So when we say that data is on a universal scale, we're talking about data that is in units that is accepted pretty much everywhere. And it's numerical data. So all you would have to simply do is if this question, let's say this exact same question comes and they ask you why was the mean calculated, you would simply say because the data was on a universal scale and because the data was numerical and it takes into account all values of a data set, right? Because there are 5 values, 3, 7, 5, 5, and 10. All of these values are being taken into account. All of them are being considered when calculating the mean. Because at times the question could even come where they ask you, why is it more appropriate to use the mean rather than median or rather than mode? You would say because mean is taking into account all values of a data set, whereas, for example, the mode may not. So you're just simply giving the description or the definition of what the mean is and what it does whenever they're asking you why it is appropriate to use this. So let's move on to the next one. So we have the median now. Median is the middlemost score in a data set. How do we calculate the median? We arrange the data in ascending order, eliminate the highest and smallest values, continue doing so until we have one value left in the middle. However, if there are 2 values left in the middle, we take their mean. So I will explain this with an example. Let's also look at when it is most appropriate or suitable to use. When data is ordinal. That simply means when it's following a certain order. That's why we're placing the data in ascending order from smallest to largest, or when it's in intervals. So again, it could be in intervals such as the data could be 0, 2, 4, 6, 8, 10, etc. And is on a scale that is devised by the researchers specifically for their study. So let me explain how it's calculated and when it's most appropriate to use with an example. So let's take 5 values again. Let's take 3, 7, 6. Let's take a repeating value 6, and let's take 1. So the first thing I would do is I would arrange the data in ascending order. So step 1 is to arrange the data in ascending order. So 1, 3, 6, 6, 7. Then the next step is to eliminate the largest and smallest values in this data set once we've arranged it in ascending order. So the smallest value is 1, the largest value is 7. So let's eliminate them. We are now left with 3, 6, and 6. We continue step 2 of eliminating. Now the smallest value is 3 and the largest value is 6. Let's eliminate these two as well. So we keep doing this until we have, as you can see, one value left in the middle, in the center. So this value of 6 is our median. Now, if we were to have two values left in the center, so let's take another example, 3, 7, 6, 6, 1, and let's add another number over here. Let's add 4. So step 1 would be to arrange in ascending order, 1, 3, 4, 6, 6, and 7. We eliminate 1 and 7, we eliminate 3 and 6. Now, as you can see, we have two values left. We can't eliminate both of them because then we would have nothing left in our data set. When we have two values left in the middle, we take their mean. So we take the mean of 4 and 6, which is simply 5. So even though the value is not present over here in this data set, because the values, the numbers are 1, 3, 4, 6, 6, 7, the middlemost value is 5 because it lands right in between this data set. And as you can notice, the data is ordinal, which means it's in order. It's following a certain order. It's in ascending order. And at times, like I said, it can even be in intervals. So when we discussed when it's most appropriate to use, the statement said when it's at times devised by a researcher for a specific study, specifically devised or designed by a researcher. So mean was for a universal scale, right? So certain values, certain units that are accepted globally, universally. Median, however, could be used for, let's say, a scale that you've developed just for your study. For example, you've developed a happiness scale, and your happiness scale is on a scale of 0 to 10, with values going from 0 to 4, 6, 8, 10. 0 being sad, 10 being extremely happy. Now, this is not necessarily a scale that is used everywhere in the world, right? This is something which I've created for my own study. So it's specifically designed for my study. It's following a certain order. It's going in ascending order. You can even go in descending order, by the way, that doesn't matter. And it's also in intervals, 0, 2, 4, 6, 8, 10. So over here, the most appropriate measure of central tendency for me to use would be median. It doesn't mean that I cannot use the mean. Of course I can, because this is numerical data as well. So at times, a little bit of confusion can arise when you have to ask yourself, am I using median or am I using mode? Sorry, am I using median or am I using mean? Which one is more appropriate for me to use, because data is numerical in both. But over here, you can clearly see that it's in order, it's in intervals, and it's on a very specific scale. It's not on a scale or a unit that is accepted globally. It's not universal. So for this particular example, the most appropriate measure of central tendency to use or to calculate would be the median. And for the first example, it would be mean. Now, I'm just giving you these examples, which I'm making up myself right now, but I will cover an entire P2 paper so that you guys have an idea of how to answer P2 questions. And hopefully in some of those papers, you will come across these questions in which they're asking about mean, median, mode, and when and how to use each of them, so that you'll get a better understanding of, or more examples of how to apply your knowledge on this matter. Okay, next. So the third and final measure of central tendency is mode. And this is the most frequently occurring value. And it's very simple to calculate. You're not even really calculating it. It's more of an observation. you're just observing the frequency. You're seeing which category in the data set has the highest frequency, which one is occurring the most. That would be your mode. So let's take an example. Let's say that students have to pick their favorite subject. So I'll write down favorite subject over here. And let me just increase the size so that you can see it. So favorite subject, and let's give you 5 options. Let's say psychology is one. Let's say math is another. Let's say biology is one, economics, and physics. Now, frequency of students who've picked these subjects as their favorite. Let's say 25 students have picked psychology as their favorite. Let's say 20 people pick math as their favorite subject, 10 pick bio, 15 pick economics, and 15 pick physics. So over here, I have 5 categories of subjects: psychology, math, bio, economics, physics. And in order to calculate the mode, I simply have to see which category or which particular subject is being picked the most. So that would have the highest frequency. That would be the one that is being chosen the most, is the most frequently occurring score. So as I can see over here clearly, psychology is the one that is being picked the most by the students because it has the highest frequency. 25 students have picked psych as their favorite subject. This makes psychology the mode, okay? It's not 25. 25 will not be the mode. The mode is always the category. We use the frequency to determine the mode, but the mode will always be from the category. So I've given an example over here as well. If you read, it says people who are asked to select their favorite color. And I've given 4 examples: red, yellow, blue, and green. So these are your 4 categories. 10 people pick red, 7 pick yellow, 12 pick blue, and 8 pick green. So clearly over here we have blue with the highest frequency. So the mode would be blue as it has the highest frequency of 12. Now, at times, there can be certain categories, certain values that may have the same highest frequency. So let's say math and physics both had 25 students who picked these respective subjects as their favorite. In that case, both psych and math would be the mode. So that would be a bi-model score. It can even be more than that. You can have a tri-model where there would be 3 categories with the highest frequency. So it's possible to have more than one mode. Now, when do we use the mode? When is it most appropriate? It is used for data that is nominal. Now, nominal means in categories. So just like over here, these are categories of data. So every time you have categories: favorite subject, um, favorite color, or let's say, for example, you have, I'll take the Baron Cohen study as an example. There are 4 groups: group 1, group 2, group 3, group 4. Um, so those are 4 categories of groups, and we can see um, the mode of the ICE test, you know, um, which particular group had the highest score in the ICE test, or what was the most frequently occurring score in the ICE test, which was 24 out of 36, which means that 24 was the value that was chosen the most, or 24 was the score that the participants scored the most out of 36 in the ICE test. So it's basically a category of data. Every time we have category of data, we say data is nominal. It's in categories, and we would use mode. So wherever you have categories, immediately identify that over here, mode would be most appropriate to use. Every time data is ordinal and it's on a specific scale, we would say median is most appropriate to use. And when it's simply numerical and on a universal scale, we would say that it's mean that is being used, and it takes into account all values of a data set. So that is covering the measures of central tendency: mean, median, mode. The second topic is measures of spread or dispersion, also called descriptive statistics. You should know all of these terms. And Where we had three measures of averages, measures of central tendency, over here we have two measures of spread, range and standard deviation. So let's look at these now. Now, range is used with the median when data is ordinal or in intervals. So we know median is used when data is ordinal. Range is used with the median. It's used in conjunction with the median, which is why for range, we also use data which is ordinal or interval. Now, what is a measure of spread? So measures of central tendencies are average scores. We know what averages are. We just discussed the three. Measure of spread basically refers to how much the data is spread from your average values, which is why we are using these average values of mean, median, mode with these two measures of spread. Because it simply means, let's say, students score an average of 15 out of 30 in a test, okay, or 16 out of 30 in a test. That's the average score that students got in a test. But how much how much does the rest of the scores, how much do the rest of the scores, the marks deviate from this middle value, this 16 out of 30? Are other students getting close to that score of 16, which basically means do majority have like around, let's say, 15, 14, 17, 18 values that are close to the mean, or is it more spread out? Do we have students who've gotten like a 2 on 30, 5 on 30, 10 on 30, 20 on 30, 30 on 30? So that's basically what measures of spread tells you. How much the data or how much the values of a data set are spread from the middle value, from the average score. Are they close to it? Are they clustered around it? Or are they spread? So range is one such measure of spread. It is calculated with the median, like I said. So median was always when you put data in ascending order. Over here, we're also putting data in ascending order. That's the first step. So data is arranged in ascending order. Now the formula is largest value minus smallest value plus 1. So I've given an example here. Just look at these values. So these are just some values in a data set: 5, 6, 3, 2, 3, 5, 7. The first step is to place these numbers in ascending order, which I've done over here: 2, 3, 3, 5, 5, 6, 7. The second step, step 2, is we apply the formula of range: largest value minus smallest value plus 1. So the largest value is 7, the smallest value is 2. So 7 minus 2 is 5, plus 1 is just something that we add in the formula every single time, which is 6. Now, the reason why we arrange it in ascending order is so that we know what the largest value is and what the smallest values are. Once we know these two values, we can apply the formula and then we can add 1 and we get the range. Now, what does this 6 even mean? Let's look at how many values there are over here. 1, 2, 3, 4, 5, 6, 7. Now, range does not refer to how many values there are in the data set because there are 7 values over here. Range is simply telling you what is the distance or the range from the smallest value up to the largest value. So how many whole numbers exist from 2 to 7? What is the distance that you have to go? How many numbers exist between these two numbers of 2 and 7? And not in this particular data set, but generally from 2 to 7, how many numbers exist? So let's write that down. So 2, 3, 4, 5, 6, 7. Let's count how many numbers these are. 1, 2, 3, 4, 5, 6. That is your range. So in order for you to get from the smallest to largest value, there are a total of 6 numbers. That is simply what the range is telling you. And again, if they ask you why the range is used or when it should be used, you will simply say because data is ordinal or in intervals and is used with the median. So very simple formula to apply if they ever ask you. Okay, next we have the standard deviation. Standard deviation is the second measure of spread, and it is used with the mean when data is numerical and The reason, so again, they could ask you, why is it better to use standard deviation as opposed to range? Your answer for that would be because just like the mean, the standard deviation also takes into account all the values of a data set, right? So that's because it's using the mean, which is why we know that the mean uses all the values of a data set. So similarly, standard deviation would be doing the same. Now, the formula for standard deviation is this very scary looking formula. So it basically looks like this. We have under root sigma, this is the sign sigma, which means sum of x minus x bar whole square upon n minus 1. Now, just looking at this, many of you might get a little scared. You know, are we required to remember this formula? Well, to be fair, no, you're not, because they've never really asked about the formula. And like I said, they won't ask you to ever calculate anything. For those of you who've taken math, you might be familiar with this formula, but I will not go into too much detail about this because I don't want to scare you guys off. If anyone is interested in learning a bit more in detail about what this formula is and how it works, you can message me privately. You've got my contact details, and I can explain this to you in a bit more detail. But for now, let's focus on the important stuff for paper two about standard deviation, which is how it's calculated, how it's used, and when it should be used. So it's used with the it's used with the mean, and there are two steps we follow: mean plus standard deviation and mean minus standard deviation. So let's say that, and I've given an example over here, the mean age of students in a class is 17 years. And let's say that the standard deviation has been calculated as 1. Okay, so we know the standard deviation is 1, and now we need to apply the standard deviation. So there are two steps: mean plus standard deviation and mean minus standard deviation. Um, Apologies for the editing over here. The 17 should actually be over here at the bottom. So this is 17 plus 1, which is 18, and 17 minus 1, which is 16. Now, what do these values of 16 and 18 even mean? So this is simply telling us that in our data set, the students of our classroom have an average age of 17 years. Okay, so let's say we have a class of 20 students and their average age is 17 years. Now, I don't know how much the data is spread from this age of 17, this average of 17 for the other 20, for the majority of the 20 students in my classroom. Yes, the average age is 17, but are the students also around about close to 17, like 16, 18 years of age, 15, 14 years of age, etc.? Or do we have someone who's a 10-year-old in the class and someone who's a 30-year-old in the class? Because remember, you can still have a mean of 17 with a very diverse age range. You can have someone who's minimum 5 years old, you can have someone who's maximum of 50 years old, and you can still have like an average age of around 20, 25, etc. So, or even 17. So it doesn't really matter what the values are, you could still get the mean of 17. But the standard deviation actually helps you kind of narrow down the range of values or how much the other values or the other ages of the students are in this classroom. So over here, we know that the standard deviation is only 1, which means that yes, even though the average age is 17, there's around, the rule of thumb is that a 95% estimate is taken, because obviously this is not 100% accurate, but we can be 95% sure that the students in this classroom, the 20 students, are aged anything between 16 to 18. Okay, so they're pretty close to this average age of 17. It's not like we have students who are 10, 11, 12 years and some who are like 20, 21, because it would be a very strange classroom if we have students of every age. But in this particular example, that is not the case. The students are age 16 to 18. There could be a possibility that there might be one or two students who might be 15, might be 19, but 95% rule of thumb, students we can assume to be within this standard deviation of 1 year, which is 16 to 18. Let's say the standard deviation was calculated as 10. If the standard deviation was 10, then it would be mean plus standard deviation, which is 17 plus 10, and mean minus standard deviation, which is 17 minus 10. So that would be 27, and that would be 17. No, sorry, 7. Sorry, my math just wasn't mathing over there. So 27 and 7. Um, so for this particular data set, we can see that there is a very wide dispersion or spread. We can expect the people in this group to be aged 7 to 27 years of age, but their average age is going to be 17 years. But now the ages of the people are not very close to the mean of 17. It's more spread out. That is basically what the standard deviation is telling you. And again, like I said earlier, if a question comes, why it should be used or when is it used, we simply say when data is numerical. Whenever you see any numerical data, all of the data being taken into account, you would say that the standard deviation is the measure of spread being used, and it is preferred over the range because all values of the data set are being taken into account. Now, make sure if the question is asking you what is the measure of central tendency that should be used, you don't write range or spread, because measure of central tendency is mean, median, mode. If they ask you measure of dispersion or measure of spread, then you would say range or standard deviation, whichever one you think is appropriate to the question. Now, hopefully you've understood that. If not, you can obviously message me and ask me for um, detailed one-on-one explanations. I'm more than happy to provide you guys with any queries, with answers to any queries that you may have. Let's move on to the third topic now, the third and final topic, the graphs and the charts. This is pretty easy. There are 4 in total, so let's look at each one of them. The first one is a bar graph or a bar chart. Now, there are 2 characteristics of a bar graph, and it's pretty easy to know these, to remember these. The first characteristic is that the x-axis, because every bar, every chart we know has, every graph has a y-axis, which is this vertical line, and an x-axis, which is the horizontal line. Now, on the x-axis for a bar chart, we will always be plotting categories. Okay, so whenever we have categories of data, for example, favorite type of movie, comedy, action, romance, drama, sci-fi. So these are all categories. This is not numerical value. These are not numerical values, are not numbers, these are categories. So whenever we have categories of data and we're using a bar chart, the categories will be plotted on the x-axis. And the y-axis will always have the frequency. So over here, the number of people who are picking each of these genres as their favorite movie type. So the second feature of a bar chart is that the bars, which are these buildings that we make for each of these categories, they have spaces between them. So you can see they're not joined together. They have a considerable amount of space between them. So these are the 2 main categories that you should know about a bar chart, that it is plotted for categories of data and that the bars have spaces between them. And obviously the tallest building, the highest bar, is going to be the one with the highest frequency. So as you can see, total of 6 people picked romance as their favorite genre, favorite type of movie. So one thing which you can probably see from this graph is, it's also written over here, we can identify the mode, because these are categories. We know that mode is used for categories of data, and we can see that this is the tallest building. So majority people have picked romance, so the mode would be romance. So this is the bar chart. Another type of chart is the histogram, which is the one over here at the bottom. 2 features of histogram. The first feature is that numerical data is being plotted on the x-axis. And again, frequency is on the y-axis. The second feature is that there are no spaces between the bars. The only way we would have a space between the bars is for example, between 150 to 200. There was no value over here. Then that would be the only way that there would be a bar over here. Otherwise, as you can see, the buildings are joined together, unlike in a bar chart. And the data is always plotted for numerical values. So over here, we have the height of trees. So These are the different values of height in centimeters: 100, 150, 200, 250, 300, 350. And on the y-axis, we have the number of trees. So a histogram is actually useful for calculating the mean. Sorry, not the mode. I was going to say mode, but the mean, because we have numerical data. So histograms are used to plot numerical data. And again, as you know, whenever numerical data is involved, whenever all values of a data set are being taken into consideration, the mean is the most useful measure of central tendency. The next graph we have is called a scatter graph or a scatter plot or even a scattergram. I've given all three terms over here. This is a graph that is used to plot correlations. Okay, so positive, negative correlations. So, and there are four types of graphs, actually five, that I'll give examples of. So I'll draw them over here. Now, again, we have the y-axis and we have the x-axis. Now let's take an example of two variables. Let's say height and weight, because that's the example I used in my research method notes on correlations as well. So over here, it doesn't matter which variable you plot on the y or x axis, because in bar charts and histograms, it did matter because it's usually the frequency that is plotted on the y axis, and it's always numerical data on the x axis for histogram, and it's categories of data on the x axis for a bar chart. Over here, you can plot either of the two variables on their x or y axis. It doesn't matter. The trajectory of the graph will always remain the same. So let's plot height on the y-axis and weight on the x-axis. So these are my two variables. Now let's say that the graph for height and weight, the scatter graph, looks like this. A really steep upward sloping curve. This is an example of a very strong positive correlation. In a scatter graph, any upward sloping curve is depicting a positive correlation. So through this, we can see that height and weight have a positive correlation. And because it's really steep, that is letting us know that it is a very strong correlation. So the two things we look at in a scatter graph: the slope, the direction of the slope, is it downward or upward? If it's upward, it's a positive correlation. If it's downward, it's a negative correlation. And the second thing we look at is how steep or flat the curve is. If it's a steep curve, like we can see over here, then that is letting us know that it is a very strong correlation. A flat curve, however, would indicate a weaker correlation. So if height and weight were, let's say, to have a curve such as this is still upward sloping, but it is not as steep. It's slightly flatter. It is almost horizontal to the x-axis. So this would be an example of a weak positive correlation. So it is positive because it's upward sloping, but it's not a very weak one. The first one is an example of a strong positive correlation. Now let's look at examples of negative correlations. So I'll take the same example I took of in my research method presentation. I think it was, I don't remember what it was. Was it time spent on social media and happiness? I think that was it. So let's write over here, time spent on social media, and on the x-axis we'll plot happiness. Now let's assume that the more time you spend on social media, the less happy you are. Let's give it a downward sloping curve. This is an example of a very strong negative correlation. The reason this is a negative correlation is because it's downward sloping, and it's strong because it's a very steep curve. So this is letting us know that the more time you spend on social media, the less happy you're likely to be. It's a very strong chance that that would happen. In the Baron-Cohen study, we looked at a correlation between the ICE test and the AQ test. So we had the ICE test and the AQ test. If you remember the results of that study, these two tests had a negative correlation of minus 0.53. So a negative correlation would mean it's downward sloping. 0.53 is not a very strong correlation. At the same time, it's not a very weak correlation. It's an average strength correlation. It's like a 53% chance that if you score high in the ICE test, you would score low in the AQ test and vice versa. So it wouldn't be a very flat curve. It wouldn't be a very steep curve. It would be somewhere in the middle. So the ICE test and AQ test could have a correlation coefficient of, it was minus 0.53. So the slope would look something like this. Okay, so flatter than the example on the left. Not very steep, not very flat. So this would be an average strength negative correlation. If it were a really weak negative correlation, then it would look something like this, almost completely flat. And if there is no correlation between the two variables, then you can just plot some dots all over the place, and you can kind of show that there is no line that is going straight through upwards or downwards. So this would be an example of no correlation. So here is a better drawing if you wish to see. Detailed notes on this entire presentation can be obtained. If you desire, you can just contact me and I will send them to you. If you're part of the group, on the WhatsApp group that I've created, then you may already have access to those notes. So here's a strong positive, strong negative, weak positive, and weak negative correlation. And this brings us to the very last curve now, the very last chart or graph. This is called a normal distribution. Two things we need to know about a normal distribution curve. It is perfectly symmetrical, which is why it's also called a bell-shaped curve, because as you can clearly see over here, it is shaped like a bell. It's following this shape where it's going upwards and downwards, so it's shaped like a bell. It's completely symmetrical from both left and right side. So that's one feature. The second feature is that the mean, the median, and the mode are all the same value. So this point right at the center of the curve is your mean, median, mode. So over here, the value is 0. Your mean, median, mode are all the same value. This is an example of a normal distribution curve. It is simply telling you how much the data is spread from the central value. So remember standard deviation? This is basically what it's telling you. So let's take the example that we did. Let's change these values for a bit. We know that the average age of the students in our classroom was 17 years, right? So we'll put 17 in the middle. So let's assume our mean, median, mode are all 17. So that is the middle value of the data set in this normal distribution curve. Now, our curve had our data, the standard deviation, let's say, was 1. It was 1 that was calculated in that example, right? Let's change that for a bit. Let's say that the standard deviation was 3, okay, because that's what's drawn over here. So if the standard deviation is 3, then that means that the values of this data set would be 18, 19, 20. 3 values greater than 17 and 3 values less than 17. This is simply telling you that the youngest person in this classroom is 14 years and the oldest person is 20 years, but because it's at the bottom of the normal distribution curve, it probably means that there are not many people who are of these ages, 14 and 20. We know that majority of the people are around about 17 years of age, which is why the height is the highest or the tallest at 17. A good chunk of people are probably 16 to 18 years as well. We have a few who are around 15 to 19 years as well, but majority people are 17 years of age, which is why this is the tallest. That's why this is the mean or the average. So this is simply telling you how much the data is spread from the middle value. If the standard deviation was, let's say, only 1, and it is only up to 16 and 18, then we would have a much more narrow normal distribution curve. It will look something like this. So the more the data is spread, the wider the curve, and the less the data is spread, the narrower the curve. All we need to know is that this is plotted because the question has come only once, I believe, on normal distribution, in which they asked once or twice, I think, in which they asked you to describe features of a normal distribution curve. And one of them was that it's perfectly symmetrical, another is that it's bell-shaped, and the third is that the mean, median, mode are all the same values. So I hope this presentation was helpful. I tried to keep it relatively short. Um, I will be back now with a video on hypothesis and operationalization that I will also try to keep relatively short. With that, we would have covered everything that we should know for research methods, because I've posted a 2-hour, 45-minute presentation on all the research method terminology, strengths, weaknesses, everything that's required that you're required to know about research methods, excluding this presentation and, like I said, the one that I'm about to make on hypothesis and operationalization. But once that is done, then I will do a few examples of P2 questions. I will explain to you guys on how to solve P2 questions, what the structure of a P2 paper is, and how to design your own study as well. There's a 10-mark question at the end of paper 2 where you have to design your own study. So we'll be focusing a bit more on paper 2 content for now. And I think this month, January, will mostly be just on that. And I will try to post as much as I can, more frequent content, hopefully. I want to then get into paper 1, how to answer paper 1 questions. And I will also be uploading other studies as well. I believe I have the whole biological approach left to upload, and 2 studies in the learning approach, Bandura and Saavedra-Silverman, and the Milgram study. So I'll be uploading all of this hopefully soon. So stay tuned and I'll keep you guys posted on the WhatsApp group. So see you guys soon. Take care. Bye bye.